Hello, I'm Allan Matthews from Sheffield University, and my role today is to introduce you to the report of the Special Interest Group on Surface Engineering and Advanced Coating, which we call SEAC. The team comprised the working group listed on the second page of the report and an advisory group also listed on the same page. You will see that the groups had considerable involvement from industry and from professionals with a wide knowledge and experience of this important industrial sector. In fact, the advisory group was chaired by David Rickaby, who is Rolls-Royce's corporate specialist in surface engineering. David unfortunately had to be at meetings in Germany this week, and that's why I'm standing in for him today. There have been 6 full meetings of the SEAC Advisory Board held at 6 weekly intervals up to the end of last year, and then once this year to review the outcomes of the Strategic Engagement Workshop held in January, and to help shape the recommendations. Additionally, there have been 2 telephone conferences to help plan the Strategic Engagement Workshop. And the membership of the group was drawn from end users and from the supply chain for SEAC technologies. So, for example, we had David Rickaby from Rolls-Royce representing the aerospace sector, Ken Brummett from Dupuy representing healthcare, Ken Scott Lockyer from E.ON representing the energy sector. The oil and gas sector was represented by Monitor Coatings in the form of Brian Alcock, who also represented the supply chain. Further supply chain representation came in the paint sector from Andrew Burgess from Akzo Nobel and from Brian Norton from Indestructible Paints. The measurement and standards sector was represented by Mark G of NPL. I represented academia, and support agencies were represented by Graham Hillier of the HVM Catapult. And the SEAC SIG was run as a collaboration of 3 parts of the KTN organisation, led by the Materials KTN and supported by the Chemistry Innovation KTN and the Nano KTN. Additionally, we involved and canvassed the views of other workers and other sectors where SEAC technologies have a role, both through direct questioning and through involvement in the workshops. The additional sectors included food and drink, automotive, built environment and space. The working group, that is the SEAC team plus myself, Dave Rickaby and Graham Armstrong, was set up to examine strategic issues in more detail, and they met 4 times between December and May, with the SEAC team working to refine strategic issues and the recommendations. There have been 2 workshops involving the wider SEAC community, a stakeholder workshop on the 11th of July 2013 at IOM3, which had 47 delegates, and a strategic engagement workshop on the 15th of January 2014 at MTC in Anstey, which had a further 38 delegates. The intention today isn't to make a detailed presentation on the report, but just to introduce you to the report, to its highlights and its key points. The first point to make is that the sector has been confirmed to have a very significant economic value to the UK economy. The group, in particular Keith Harrison and I, together with input from organisations such as the Institute of Metals Finishing, revisited market value figures in the report which Richard Artley and I had produced for the Surface Engineering Association in 2010, and we were able to confirm the following. Firstly, that the value of the coatings industry, both in-house and subcontract in the UK, is about £11.2 billion annually. The value of products produced directly affected by coatings is about £140.3 billion per year, and the turnover of companies which make extensive use of coatings is about £383 billion annually in the UK. So that last figure is an increase of about £130 billion on previous estimates as a result of our inclusion of sectors such as food and drink, which weren't included in the previous report. So the economic impact of the surface coating sector in the UK's industrial and commercial activities is truly huge. As already mentioned, the SEAC study team met regularly over 15 months and also held open meetings to consult with interested parties in the sector, not only coating companies themselves, but also end users of coatings, as well as the academic research and training base. The team recognised that the UK research base is well regarded throughout the world, but it was also recognised that this strength had been achieved with rather minimal cooperation between research groups. It was felt that if the research base is to continue to operate at the leading edge and to stay ahead of overseas competitors, greater cooperation will be needed. In particular, a number of key targets were identified for the research base. Firstly, better methods are needed to characterise, measure and record key performance information. This includes the identification of reliable accelerated tests. Within this goal comes the need for life cycle simulation and analysis. Secondly, there's also a need to support more applied and industrially relevant research, which can lead to product innovations reaching the market more quickly and with the proper knowledge of the influence of process variables on the reliability and robustness of an applied coating. Thirdly, the research base needs to improve technology transfer by encouraging cross-sector exploitation and increasing awareness and access to production-capable equipment. And this may involve the establishment of pilot plant and demonstrator facilities in the UK. Clearly, we must address issues relating to sustainability and to the environmental impact of coating systems, mindful in particular of the impact of regulations such as REACH. A key challenge identified by the team was how do we maximise the value from innovations in the SEAC technologies. This led to the question, how can we ensure that SEAC supply chain becomes a strategic element of high-value manufacturing? Improved integration of surface coating into products, developments and manufacturers is needed, especially in the early design stages. The need is to proactively incorporate coatings rather than reactively incorporating them as a sticking plaster or band-aid solution to a problem. The report includes diagrams which illustrate the processes by which coatings can be considered during the design and development cycle. So it is the SEAC team's view that what is needed is for the UK to create a community of end users, academic groups and coating producers with a pre-competitive common objective to establish a toolbox of design and verification and technical and commercial capabilities in the field of surface engineering and advanced coatings. The team looked at what had been done in other sectors, such as metrology and composites materials, and saw that the following steps would bring advantages. Firstly, to create a network or leadership forum which would promote improvements in design and substitution of materials and coatings. Secondly, to move from reactive to proactive design. Thirdly, to marry the science and art of surface coating with real-world specifications and performance standards. And fourthly, to create testing methodologies which allow the impact of coatings on performance and life cycles to be managed and controlled at known risk levels. And then finally, the research community should deliver knowledge, skills and effective communications between different disciplines and industry sectors and renew the skills base. The supply chain needs to embrace the digital age more effectively. For example, process control should be automated and verifiable. So the team has taken each of the points which I have highlighted so far and has set out 6 recommendations which are indicated in the report. And I hope that you will take time to read those carefully. The SEAC team is keen to receive feedback on the report, and we hope that it will lead to improvements in the way that UK industry fosters, adopts and utilises surface engineering innovations in its products. Just a word about the proposed leadership forum. It's aimed at developing the manufacturing innovation ecosystem. That's a self-contained, self-sustained, self-generating, self-funding ecosystem involving innovation and manufacturing. And further, to provide more effective flow of technology and information between the companies and researchers within the sector, and to enhance capabilities to meet these productivity and competitiveness challenges. The model proposed is being used effectively in areas facing similar issues such as metrology and composites materials. In the latter, a composites leadership forum was set up, and these networks bring all parts of the supply chain together to address cross-sectoral issues. So a key finding from the report is the need to bring people together, and we hope that that will begin with this event this evening.